Hello everyone, I'm Ivanov Faiz. I want to tell you about my research. The title is Analysis of Fish Waste and Co-Substrate Mixture on Biogas Production and Solid Waste Reduction in an Anaerobic Digester. This is the table of content on this presentation. I'm Ivanov Faiz. I studied at Environmental of Engineering Master Program, Department of Civil and Environmental Engineering, Faculty of Engineering, Universitas Indonesia, Depok, West Java, Indonesia. Introduction. There are so many potential in Indonesia. First, Indonesia is maritime country dominated by 77% of its territorial waters and 23% of its land area with 70,500 four islands. And in the second, there were approximately 62,388 fish processing units spread across Indonesia in the form of micro, small, and large medium enterprises. And then there are many potential of fish waste in Indonesia. First, fish waste management in Indonesia has not received much attention up to this point due to the country's generally still very conventional approach to fish management. And the second, in the management of marine product, fish waste is the biggest problem because fish processing waste has a proportion of 30 until 40% of the total weight of fish consisting of heads, bones, fins, skin, and oval, while liquid waste can come from fish blood and fish wastewater. There are so many processes to treat fish waste, but I choose an aerobic digester because an aerobic digester is the simple technology and we can convert the waste to an energy. There are some research to support the anaerobic digester technology. First, based on research by Kadafit, the analysis research estimate the annual energy production generated from using 509 tons of fish waste can producing 489 megawatts per hour of energy that can satisfy 230 fishing families. And the second, based on the research by Sodic, using two variation of substrate mass composition of organic waste and fish waste that can result biogas production and methane gas in reactor A and reactor B. In reactor A, we got 69 liter per kilogram for VS and reactor B 67 liter per kilogram VS. And for methane yield, in reactor A, we got 11 liter methane per kilogram VS, and reactor B is 8 liter methane per kilogram VS. So what barrier does fish waste present? Yeah, high concentration of ammonia and long-chain fatty acid found in fish waste could lower production of methane gas during the anaerobic digestion stage of the biogas production process in anaerobic digester, consequently resulting in lossy and circumstances. Yeah, if I just use a fish waste, the CN ratio is just 8.65. So for optimal process in anaerobic digestion, we need a CN ratio to 27 until 35 CN ratio. So I balancing with another substrate like organic waste, cow dung, and sawdust. The research objective, the study aimed to evaluate the anaerobic digester process in terms of solid reduction, biogas productivity, and performance. This is the reactor design that I use for this research. The reactor was constructed out of cylindrical fiber and had dimension of 110 centimeter in diameter, 160 centimeter in height, and 1,200 liters in volume. The reactor is divided into two parts, but parts are separated by a diaphragm to separate the substrate that has not been processed at the bottom and the substrate that has been processed at the top. Okay, this is the research methods. There are four steps. First is preliminary study, testing of the initial characteristic of the substrate for parameter total solid and volatile solids. This is the result of the initial testing. And then the percentage ratio of the composition that I use in reactor A is 40 for fish waste, 40 for food waste, 15 for cow dung, and 5 for sawdust. And for reactor B, 30 for fish waste, 30 for food waste, 20 for cow dung, and 20 for sawdust. Organic loading rate for feeding an anaerobic digester that I use is 2.5 kg Vs per meter cubic per day. This is the formula to calculate the substrate mass. And then this is the substrate mass calculation. For reactor A, I got feeding amount 8.89 kilograms, and for reactor B, I got 6.29 kilograms. And then the second is acclimatization process. The acclimatization process took on 5 weeks. For example, week 1, we got feeding to reactor 20% from feeding amount. Until week 5, we got feeding to reactor 100,000 from feeding amounts. And then the operational and experiment process, a freezer is used to ensure nutrient stability. And the operational process took 3 weeks, with the feeding process is carried out 5 times a week. The parameter measurement the parameter measured in this study are pH, temperature, total solid, and volatile solid, gas volume, and gas composition. The research data analysis, I use software SPSS 25. And then this is the result from my research. This is the temperature parameter measurement research. The conclusion is the comparison of temperature measurement in reactor A and B shows a difference that is not much difference, but substrate measurement at the input and output point. And then for pH parameter, the conclusion is the comparison of pH measurement in the reactors A and B show difference that is not significant from both substrate measurement at the input and output point. And then this is the result of total solids and volatile solids parameter. Uh, from total solid input and total solid output, we got total solid reduction, and reactor A has an average 97.42%, and reactor B has an average of 97.95%. If we compare with research by Sodix, which only use food waste and fish waste substrate, may have a lower reduction value 30.40% than the result of the two reactors. And then same with the VSD, an average in reactor A is 67.87%, and for reactor B is 40.36%. And if we compare with research by Sodic, we got VSD from two reactors have a lower than research Sodic. Okay, and then this is the result of biogas composition. Reactor A had an average methane content of 57.50%, and for carbon dioxide is 32.15%, and for hydrogen sulfide is 0.23%, and for reactor B has an average methane content of 66.44%, and carbon dioxide an average 37.23%, and for hydrogen sulfide is 0.09%. And then based on another research from Salam, biogas is generally composed of 55 until 65% methane and 35 until 45% carbon dioxide, and 0 until 3% nitrogen, and another gases. And then this is the result for biogas volume. Based on the result biogas volume measurement, it was found that reactor A produced biogas on average 155.8 liters per day, and reactor B produced biogas on average 133.56 liters per day. And then for methane yield calculation, for reactor A, result that methane yield is 122.37 liter methane per kilogram Vs, and for reactor B is 131.76 liter methane per kilogram Vs. The conclusion of this research is, based on this research, it can be concluded that processing into biogas with an aerobic digester method using substrate of fish waste, food waste, cow dung, and sawdust at a composition ratio of 40, 40, 15, and 5 for reactor A, and 30, 30, 20, 20 for reactor B can be done effectively. It can be seen from the solid that have been reduced to 97.42% for reactor A and 97.95% for reactor B, and generate 155.8 liters per day of biogas in reactor A and 133.56 liters per day of biogas in reactor B, with an average methane content of 61.9%. And then the reactor A yield an average of 122.37 liter methane per kilogram Vs, while reactor B yield an average 131.76 liters methane per kilogram Vs. The result of the research indicate that there is no significant difference between the composition ratio in reactor A and reactor B with regard to to reduction, and then biogas volume or methane yield. As a result, the two composition ratio can be used to determine the composition of waste treatment using an anaerobic digester. This is the documentation of this research. Thank you. Thank you for your attention.